Okay. Hi, everyone. Everyone is seeing me? Because I see something saying open system preferences. Yes, you see me? Okay, perfect. Um, so, thank you for coming. Gracias a todos. And, well, this is another event from the Barcelona Java user group. And today we are very happy to have Cătălin again with us, and this time talking about Spring and integration testing. So, hi, Cătălin. And
hello, nice to meet you again virtually this time.
exactly.
Last time was live, face to face.
A great and beautiful city, Bucharest, and you showed us, and you were an amazing tour guide. So let's see what you have for us in terms of explaining how can we use Spring Framework for integration testing. I'm going to share my screen, and I hope that you will all see. Okay. Do you all see my screen? No. Okay. That's what I thought.
No.
Okay. Apparently, this is something related to, okay, with the, oh, also, okay, 1 second. I didn't try this. Content of your screen until it's quit. Oh, and I'm using. Okay, probably I will disappear and appear again. Okay, now you see me.
I see you, I think.
Okay.
Let's see with your screen.
Let's see. Okay. Now you see my screen, right?
Mm-hmm.
Yes? Perfect.
Yes.
Okay. Sorry for this inconvenience. So, well, today, as I said before, we are going to see a very nice presentation about integration testing with Spring by Cătălin Tudose. But basically, what I want to is just to simply introduce the Barcelona Java user group. If you haven't been before in any of our meetups, please say it in the chat, or I will add a poll right away after my presentation, just in order for us to see how many people are new to the Barcelona Java user group and who are well, like a person that has been several times in the past with us. So, well, we are a nonprofit open group now with more than 2,000 members in Meetup, and we've been running since 2012, doing several meetups each year. We tend to do 2 per month, but depending on the season, we do more or less. But basically, it's about two per month. Now we are hosting a virtual event because Cătălin is living in Romania. So, yeah, it's easy for us to have him here sharing knowledge with all the community. But sometimes we do in-person events. We are hosting several events in different companies in Barcelona. So just, check our meetup and you will see the different events that we are going to host. We are always open to discuss several technologies, not only Java, because we have done several meetups or events regarding different technologies. We have several ways to be contacted. The barcelonajac.org website, but it's not very up to date. I would recommend that you go directly to meetup.com. Also follow us in Twitter with Barcelona Java User Group. Also, you can check our photos for our past events or our past conferences in Barcelona Java User Group at Flickr and Instagram. And also you can check the videos as this one that we have had in the past in our YouTube channel. As I said, we have covered different technologies from Spring to Kubernetes, Docker, Neo4j, Quarkus, or Apache Camel. So not only Java, different technologies. And today we need to thank our sponsor because they are giving us the technology to host this event virtually, this crowdcast event. So thank you, Jakarta, and please check their website because you will see, well, how the Java Enterprise is going. So finally, I'm only want to, say that if you want to be part of our group, just ping us. You can be part of the group as a volunteer, helping in organizing things, as a speaker, proposing some talks, and also as someone that wants to receive a talk about a technology, a specific one. So you can say, okay, I would love to have a talk about, I don't know, VMware Tanzu. I don't know. So then what we can do is just to ping someone from VMware or another company that can give a talk about that technology. So yeah, please ping us if you can be a speaker, if you want to have a talk, if your company can provide a place to host events, whatever. You will help the community and we will appreciate. Here you can ping us in our email account or even go to Slack and chat in the different technical channels or even ping us there about requests or comments. Well, for today's event, we have Cătălin Tudose, experienced software engineer, teacher in the university, doing courses about Java, Spring, Hibernate, design patterns. He has even done a meetup here in the past about Cucumber. So yeah, he knows a lot about Java and also about testing. And today he's going also to share how to combine this integration testing with Java and with the Spring framework. So this is all I had to say. Now it's the turn of Cătălin. So Cătălin, the stage is yours.
Hello, everybody. Thank you, Jonathan. Thank you. Thank you for being here. I will start immediately our meetup. I think that now you can see my screen, yes?
Yes.
Okay, great. Integration testing with Spring. This is the topic of our talk today. About me, I agree with everything that Jonathan said. Additionally, to tell you, I'm born, raised, and currently living in Romania. I am acting as a Java and web technologies expert at Luxoft in Bucharest, Romania. I have a PhD in computer science. And besides what Jonathan was saying, I'm author of 6 courses and 1 project at Pluralsight, mostly topics on Java, Spring, Java testing, Java persistence, and author at Manning with two books. This JUnit in Action that was published in November 2020, and Java Persistence with Spring Data and Hibernate. It is currently under publishing. It will be soon available in its full version. Thank you again for being here. We would like to talk about integration testing, and more exactly about integration testing with Spring. Just to review something about what testing means, how it is done. First of all, looking at this testing pyramid, we think about correctly the correct way of working of our units. When we say about units, we are thinking about methods, classes. That's why we say that unit testing is at the ground of our testing. But the fact that the units work correctly is not enough. They need to integrate with each other. And this is the second part of the pyramid, the second level of the pyramid. And it is here where our talk, our demonstrations, our analysis will focus. We need to make sure that our code is correctly integrating with some external services, with some databases, and that we do not depend much on some random behavior from their side, and that we really test the correct functionality of our code. And if it fails, it is something wrong with our code and we need to correct. Just to mention here that we also have the system testing level, where we deal with the testing of the whole system, and the acceptance testing level. We say, okay, our system is functioning fully correctly, but is it addressing the user's needs? This is acceptance testing. Does our system what it needs to do besides doing things correctly? But again, we are focusing at the level of integration testing. And in Spring, we have this Spring TestContext Framework available for us. We are going to analyze it a little soon. Just to say for now that a generic annotation-driven integration testing support, and important is agnostic of the testing framework. So you can test with JUnit 4, with JUnit 5, with TestNG. Spring TestContext Framework will work with any of them. Of course, we are doing our test with JUnit 5, which nowadays is the most widely used testing framework. And to start our demonstrations, we have here an application that would like to integrate with a database. What we would like to test is, of course, the functionality of our application. And as I was saying, if it fails, we have to be sure that it is because of something on our side and not because of some behavior on the side of the database. So what we have here, we have two entities, user and log, that represent the entities that we manage and that we would like to persist on the side of the database. In order to do this, we created two repositories, a user repository that is managing entities of type user having IDs of type log. When we say extends JTA repository, it means that it is inheriting the behavior provided by the JTA repository, and automatically Spring will create a bin that will be able to interact with the database, and that will be able to manage the user entities. And we say, okay, let's think about what to test. Created here a Spring Boot test, auto-wired this user repository, and say, okay, let's do some testing. A simple test that says, let me save the user, then let's query the database, find all, and as I saved one user, say I want to retrieve that user, I want to be sure that the length of the collection of the user that is retrieved is 1, and this is the user. A very simple test. It takes a little to run, but that's it. You'll see that we are already using a MySQL database that is close to what is happening in real life. We consider that it is appropriate for our investigation today. So, okay, saving one user, retrieving that user goes fine. But what if I am using this nice feature of JUnit 5 about repeated tests, saying, okay, if I am running this test, I can repeat it and save the user, retrieve it, check, save the user, retrieve it, check. Why not try with this repeated test annotation with this parameter of 2, expecting to interact twice with the database, and let's see what is happening. It takes a little, of course, but we'll encounter something interesting. Okay, it is triggering. It interacts with the MySQL database. It will repeat twice the test. A little patience because it is executing. Okay, something happens. You see, first repetition is successful. Second repetition fails and says, I was expecting here 1 user size 1, but I found 2. Comparison failed. So if I go here in the MySQL database, I have set up here everything, and I'm saying select all from user. I'm going to see that indeed in this user table, I left 2 records. And I am wondering what happened. What happened is that executing this test twice did not reinitialize in any way the Spring context. So after executing the first time this test, something is left behind in the database. We say that the context is dirty. Yes. We have a first solution to apply this dirties context annotation. And it is prepared here for us at the level of the at the level of the class. So besides repeating the test, I'll say dirties context, and while it is executing, because we know that it takes a little time, we can examine the fact that dirties context is an annotation that marks the Spring application context as having been dirtied during the execution of a test means that it should close and reinitialize the context after the execution of the test. And if we want to have a look here at the dirties context functionality, we have here a little schema saying, okay, when we have a dirties context, we repeat something for each test. We create the context and cache. We do these things that are specific to Spring inject dependencies, execute before each test method, after each, which is specific to the testing framework, and then remove the cached context. So we make sure that at the repetition of each test, the context is created, cached, and removed in a loop, which is able to solve our problem, as we are going to see, but it will come at a cost, as we are going to demonstrate. So meantime, I executed this test twice with repeated test 2, dirties context. Both executions succeeded because the context was reinitialized every time. Just we keep in mind that it comes at a cost, yes, and we would like, among other things, to analyze this cost. We may ask ourselves, do we have other alternatives to compare dirties context with other alternatives? An alternative is this transactional execution. There is a transactional annotation in Spring saying this execution is transactional. And besides this, the execution of the test will make the transaction to be rolled back at the end. So we are executing the test, do our assertions checking, and we roll back the transaction. Why? Because there is a listener. We are going to come back to this idea of listeners. There is a listener that is there, and at the end of the execution, it will take care that everything is rolled back. So if we look at this second test as alternative, we see here that we have this transactional execution. We have also repeated test twice. So we would like to analyze what is happening. We would also like to trace the transactional execution. That is why I introduced here in this before all, before each, after each, and after all annotated methods, I introduced here some tracing about being or not being in a transaction. Yes.
One thing, Cătălin, how do you want to handle this? Because there are questions. Do you want to handle the questions at the end or as they appear?
Let me ask, how many questions do we have already?
One. Now we have one.
We have one. Let me finalize this demonstration with transaction, and I will take this question. Okay. Yes, just okay. So executing transactionally, we see our tests succeed because we start transaction, execute the test, do the checkings, roll back the transaction, and again. And if we trace here what is happening, because I introduced the messages here to see if the transaction is active. Transaction active. Transaction active. You see, before all there was no transaction. When the test is about to start, transaction is active. Transaction is active in the method after each, and another transaction is active, and after all, there is no more transaction. So the execution is transactional. We don't leave anything behind, because if we saved something, we do the checking here. For example, here, this is one checking, but we make sure that that transaction was rolled back. So we by simply rolling back this transaction, we make sure that we don't leave anything dirty behind us. Okay, let's take the question. We take the question?
Yeah, sure. What if the code we are testing uses transactions while using add transaction in the test?
So I think it's referring to this. Yes, here.
Yeah.
So we are using this exactly to make sure that the transaction is rolled back. By annotating our test with transactional, we make sure that the execution of such a test is in a transaction. Because there is a listener, and we are going to go back to this, that is taking care of this, at the end of the transaction, that one is rolled back. And by using this transactional, and by using transactions, we make sure that nothing is left behind. Yes, there was something there. We checked the content of the database. We checked that we successfully saved, retrieved, whatever. And after that, we make sure that we clean up after us. We will demonstrate that this is quicker, this is more efficient than using dirties context. If we use transaction and we roll back transaction, we will be sure that we leave the database in the state that was before the execution of the test. And when the next test will come, it will find the database in the same known state, will not rely on anything else, and it will check its execution without depending on some random content of the database. I think that and I hope and I think that this answers the question.
I assume that Mark was asking basically that if in your code you already have the usage of transactions and you are opening a transaction in the test, but I want to say that I think that when you use a transaction in your code, usually what you do is create or merge transactions. So if there is already open, you will join.
Have a look. Okay, this was something that we are going to, I think, maybe to demonstrate now. We have this transaction, and we introduced here, yes, on purpose, this additional transactional method, yes, that remained here a little unseen until now. You see, this is a transactional method, annotated with transactional, nothing more here. So if we start here transactional, yes, when we arrive here and we execute this method, it is also annotated with transactional, no explicit propagation. What it will happen is that it will take the default propagation value, which is propagation.required, meaning that we are inside the transaction. We find a transactional annotated method. It says required. So I'm in transaction T1. I go further with the same transaction. So everything that is executed here in this method is within the same transaction. But I can force my luck here and also demonstrate one pitfall of using transactions. I was saying that they are more efficient than dirties context, but they also need to be used carefully. Because if I go here and I will say transactional propagation requires new, and I am re-executing this test, something else will happen. I will be in this transaction one that will be the transaction of the test. And when I'm going to call that method that now has requires new, this transaction one from the test will be suspended. Transaction two will be started. It's an independent transaction. It's a new transaction. It will commit at the end. Go back to transaction one that was suspended. This one continues, do whatever, and then roll back. And if I look here, let's wait. You see that this second repetition failed now because that separate transaction here committed its work. And if I look here, so, I was expecting 100 records and I found 101. Why? Because this separate method was annotated with transaction propagation requires new, and it committed its work. I think this clarifies more on what we were saying.
Definitely, thank you.
Okay, and to compare between the two approaches, made some tests here: dirties context versus transactional with MySQL and with H2. What we have here, there is a execution time test. I'm not going to run it now because you see it takes time and it will repeat things 10 times. But what we have to emphasize here is that there is a difference, a time difference between the execution with dirties context and transaction. And what is remarkable is that no matter how many records we have here, we varied in a test from 100 to 2000. The time difference is approximately constant. So the time difference between the execution with dirties context and transactional does not depend on the number of records, but on the number of the reinitializations of the context. 10 tests will mean for dirties context 10 reinitializations of the context, and this will take a time something like this. For H2, the same. In reinitialization of the context 10 times, it will take something like this, approximately constant. So, of course, we are clearly supporting the usage of transactions for correct integration tests with Spring. Dirties context, most likely you are going to use them locally, but if you push the code having dirties context on your continuous integration machine, this may result in some delays in the execution of the test. That will happen every time. So transactional has a lot of advantages. It allows you to leave your database clean, and it takes less time. Remember, we want to clean up behind us just to make sure that next test that will come will have a known state. and they will not depend on something unusual, unknown, surprising that is to be found there. We can manage transactions with this before transaction, after transaction, rollback, commit annotations. Just to mention them here, I have already used these annotations, just to say that by default this test is rolled back. I can go and I can say here add the commit annotation, or rollback false if I want to commit on the side of the server, but most likely this will be only to do some variation testing my code before pushing it. Before moving to the next part, I would like just to have a look at something that I mentioned here. I mentioned listeners, and I was saying that there is a listener that is taking care of rolling back those transactions. And for our information, for now, I would like to see the listeners that are registered for this test. And I can take the context, take the listeners, and ask how many are you? And just for the information now, because we are going to go back to the listeners immediately. Just I'm interested now only about the fact that they exist, that they can be retrieved with the help of this test context manager, and that they have some size. Let's see which size we have. We have 14 listeners. Let's keep in mind this number, and we are going to go back to this. I'm going to close this project just to save some resources. But I think that this project has already provided us enough interesting things. Active profiles is some other feature that we can use for our efficiency of the integration testing. What is it about? When you are doing testing, and in general when you are working on a project, you may be on different profiles. You may be, for example, on the developer profile, you may be on a production profile. If development takes some time, you work locally, you would like to develop quickly, you would like the access to the resources that your code integrates with to be quicker. And for example, during the development that may take weeks or months, I would like not to work with the real database, but to work with a in-memory H2 database that is quicker. I'm focusing on my code. I see that it integrates correctly with the H2 database. I develop my code. I'm happy with it and with the tests. And when I move to production, I would like to quickly switch to another profile. Yes, to the production profile. If I'm looking here, I have something similar as code base. So I'm keeping two profiles here. How do I keep these profiles? This is a Spring Boot application. And in application.properties, I have this indication of which the active profile is. And in application.profile name.properties, for example, application dev properties, I keep here the configuration for the dev profile. You see, I'm using H2, prod profile, I'm using MySQL. And I say, I want to develop on H2, and when I move to production to quickly switch to this other profile. So here it is dev active. I'm doing that simple test that is storing, updating and retrieving a record, but I will use the dev profile because it is dev that is specified here. And I'm going to demonstrate. Okay. It's executing. Okay, it takes some time, and I was saying it is dev profile, so it is H2 database. If I'm looking here in the log, I see here dialect. The dialect is H2 according to the configuration here. And here I see that on the class path, the H2 dependency has been added. I am on the dev profile. I move to production. I want to quickly switch the tests that I wrote to integrate now, not with the H2 database that I'm using in development, but with the MySQL database that I'm using in production. So this is the configuration of the MySQL database. Takes a little. You see here already, you see MySQL. Okay, just a few seconds. Okay, and now, yes, I am using this MySQL dialect, and what was loaded on the class path are these MySQL dependencies specified for this configuration. So I can very quickly switch my integration tests depending on the profile. I can do this from the configuration. Eventually, I can go here and I may use, I may override the active profile with this active profiles annotation. This is also fine. You just have to recompile and rebuild the test, while here everything is at the level of the configuration. So one very quick way to switch between different configurations for your integration. At development, for the long run, you may spend weeks and months on some lightweight environment. And when you go to production, you want to quickly switch and to execute your tests, your integration tests against that new environment. Okay, we'll close this project as well. And go back here to the presentation. Test execution listener. We mentioned this test execution listeners. Yes. And we would like to demonstrate how to implement our own listeners, why we should implement our own listeners, how to do it, what to take care of. Why to implement such a listener? To implement a listener that will come with a separate behavior. Why? When we have annotations like before each, after each, whatever. Because it is more flexible and reusable than before each and after each. They are fine, these annotations are fine, but if you want to specify the same before each behavior for multiple tests, what can you do? To duplicate the code, but of course this is not a good option. Or to create a base class and to make your test extending that base class and to have this before each annotated methods there. This is also working, but it will make you hanging your test in a hierarchy. While here with the test execution listener, you are separating your code, your side effect code in a listener. And here, this is our own listener. So it implements test execution listener, and we have here default methods not doing anything. And we come here and say, let's do some additional behavior for before test, for after test, whatever. Okay. Having written this execution listener, I go back here to a test. I will, for the moment, I will remove this these two listeners and say, I'm having this test. I annotated it with transactional, and I also annotated it with this test execution listeners. Yes. And it is my simple test store, update, retrieve. Let's do this. Takes a little time, but I think it will be again interesting. Remember that we wrote our own listener, custom listener, and we annotated here test execution listeners, test fails. And if we take a look here, say Java lang null pointer exception, this user repository is null. So this user repository that we were previously injecting with the Spring annotation autowire is null. Why is this happening? Let's have a look at the size of our listeners. Remember when I demonstrated a previous execution, we had 14 listeners, while here we are having one. I said, let's keep in mind that number of 14. Those are the predefined listeners that are automatically registered. And here, as we are annotating with our own listener, all the other are no longer registered by default. Which one is causing the missing of which one is causing this failure? The missing of this dependency injection test execution listener, because in the absence of this one, you're not going to be able to auto-wire this user repository. I introduced this one now, and I'm re-executing the test. Okay, let's see what's happening. We are expecting to have one more listener, size equals 2, you see. And test succeeds, or maybe apparently succeeds. Because if we follow here, the transaction execution, transaction active is false, false, transaction active, no transaction here, which of course is not good. We talked so much about transactions. This is happening because now we found out that another listener is missing. We may add this one manually, re-execute this test, demonstrate that we'll have transactional executions, but of course this is not an option to add manually one by one. We did this for the sake of the demonstration. We'll have an option to merge our listener with the predefined listeners. We'll demonstrate this immediately. You see, a transaction active is true. The size is 3, 1, 2, 3 listeners. We are having transactional execution. Yes, but what we can do better, as I was saying, is okay, we cannot add manually or keep in mind whatever we need to add, but we have here a merge mode, say merge with defaults. And I'm re-executing, and we are expecting now the 14 default listeners plus this customized database operation listener to have a total of 15 listeners. It always takes a little time to execute this code, this test. So what we are interested now about is this size 15. The size is 15. 14 default plus this custom listener. So I think that was our demonstration about listeners as well. I'm going to remake here the code as it was looking at the beginning. I'm looking forward for other questions, for other things to discuss. We passed through a lot of interesting things and demonstrations, I think. Dirties context versus transactional, their performance, active profiles, execution listeners, everything is provided by the Spring TestContext Framework to help you write high quality, safe integration tests and not to depend on some random behavior of resources outside your code. So I'm looking forward to questions, comments.
Yeah, I think I see one from Alberto.
Yeah.
That asks, which is the difference using the database listener or not?
So here I'm writing my own listener. My listener implements this test execution listener. It provides some side behavior before test method, before test execution, after whatever. It provides something similar to the before each, after each, before all, after all methods, annotated methods. Here I may provide some side effects before, after the execution of some tests. I may log something, or I may check some assumptions. In the absence of those assumptions being true, I can stop the execution of the test. I can do whatever I would like to do here. I just chose for our demonstration to look at the fact that the transaction is active or not. Yes, just to demonstrate that was related to the introduction, to the absence of this transactional test execution listener. But I can do whatever side effect that I can do. In general, you may do some logging, you may do some checkings, things of this kind. In the absence, if I'm not doing this, if I remove this, all those information about transaction active will disappear because it was coming as a side effect. So if I go here and I will say, let's forget about my my custom listener, and I'm re-executing it. This side effect that is a logging here about the transaction being active or not will disappear. This is the difference on this particular execution with this particular listener.
Perfect. I don't know if there is any other questions from the audience. If you have one, now is the moment to ask.
So you see now more transaction active. Yes, I removed this. Of course, you may get in touch with me on LinkedIn, on Twitter. I am easily to be found. This is my Twitter ID. You may easily find me on LinkedIn. I have to confess that I'm more active on LinkedIn than on Twitter. If you are interested in any of my books, you can easily find them on the Manning website. I think that Jonathan has already posted a link to this Java persistence with Spring Data and Hibernate book.
Yeah.
That is related exactly to our talk, or our talk is related to the book, however you would like. Of course, JUnit in Action is all about testing, as we are doing testing, but this one is closer to our talk. It also has a chapter dedicated to testing Java persistence applications. So I'm available for questions, for getting in touch with me later, or for meeting you online again at some other talk.
I would say that Alberto has also another question. We can finish with this. So he says maybe it's a crazy or stupid question, but could you have a custom before each for every test method using the listener?
So to have a custom before each, probably I can go here and I can override only the before test method to have an effect like this, if I'm understanding correctly, to have a custom before each with listeners, I understand. So if I'm overriding only this method, I may see it as an equivalent of the before each, customized, but available for all tests that are annotated with this listener, test execution listener, database operations listeners.
Okay, so we are up to the hour. So thank you very much. It's been a very interesting talk about integration testing and
I see that I'm frozen.
yeah, you've been frozen for quite a long time.
I'm sure, yes, because this IntelliJ is very much resource consuming and it conflict. I didn't know. Now that I saw, I was supposing that I was frozen. That's it. It is very much resource consuming and it freezes sometimes the video.
Okay. Well, yeah, nothing else. Just simply to thank you for your talk, and thank you to the audience for being here. And I hope it was interesting for you. Don't forget to propose meetups or to propose yourself to be a speaker, or even just tell your company to host an event physically in your offices. Ping us and we will try to handle it. Thank you very much. Muchas gracias a todos, and have a lovely afternoon, morning, evening, night, whatever part of the day is on your side. Thank you very much, and see you
Thank you.
at the event. Bye-bye.
Bye-bye.